All right, Math 2, this is our last unit. We're going to look at probability in this unit. So we're going to start with just the general definition of what probability means. Probability means that we're going to take some kind of fraction. Our probability is always going to be our favorable outcome divided by the total possible outcomes. So what does that mean? Let's say that I've got a six-sided die here. So I got six sides. It's numbered 1, 2, 3, 4, 5, 6. And let's say that I want to roll a 1. On this die, there is only one 1. So how many favorable outcomes would there be? There would be one favorable outcome. Now, how many total possible outcomes are there? Well, the outcomes would be 1 through 6 on this die. So the probability of rolling a 1 is 1 out of 6. And usually we'll look at probabilities as far as decimal answers. So we might do 1 divided by 6 equals 0.166666, goes on forever. So we might say that this is approximately 0.167. So that's to the nearest thousands. Now let's say instead that I wanted to find the probability of rolling higher than a 4. So higher than a 4, there are 2 that are higher than a 4. I could roll a 5 or I could roll a 6. So there are 2 favorable outcomes there. A 5 or a 6 would both be favorable. So I'd say, okay, there's 2 favorable outcomes. There's a total of 6 possible outcomes. So that would be 4 divided by 6, and that rounds to 1/3. No, 2 divided by 6. 2 divided by 6, not 48 divided by 6. So I get 0.333333. So this would be about 0.333, rounding correctly. So in general, that's what we're looking at. We're just looking at what is our probability that we're going to have a favorable outcome versus how many total possible outcomes are there. All right, so we're going to start looking at and or probabilities. If I have an and probability, both events must occur at the same time to be a favorable outcome. All right, so I've got an 8-sided dice here. So there's 8 sides on this one. And let's say that I wanted the probability of rolling it an even number. And then I wanted to also have a number greater than 5. Okay, so I've got a total of 8 sides on here. So I'm just going to write them down. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 sides on there. I want one of the numbers greater than 5. So greater than 5 would be 6, 7, and 8. And what if I also wanted the even numbers? So there's 3 that are greater than 5, but of those 3, only 2 of them are even numbers. So the 6 and the 8 would be the only ones that satisfy both of those terms. So we were looking at greater than 5 and even. So greater than 5 and even means that can only be 6 and 8, because 6 and 8 are the only ones that are greater than 5 and even. Both have to occur. So greater than 6 and even, of our favorable outcomes, there are only 2. A 6 would be favorable because it's greater than 5 and even, and 8 would be favorable because it's greater than 5 and even. So we would say it's 2 out of 8, or 1/4, by reducing it, which comes out to exactly 0.25. Okay, so that's and. They have to happen at the same time. Okay, what if instead I was rolling the same die and I wanted it to be greater than 5 or even? Okay, so greater than 5 or even. That means I'd be happy with either one of those outcomes occurring. So let's write them down again. 1, 2, 3, 4, 5, 6, 7, 8. Now I am happy to have greater than 5, or I'm happy to have even. So I've got 3 of them greater than 5, and I've got 2 of them even. But I'm not going to say that there's 5 possible outcomes, because 2 of those are overlapping. 6 is both of these, 7's only one of them, and 8's both of them. So if I look at it, I only have actually 3 possible outcomes that are greater than 5 or even, because I'm happy with it being greater than 5 and I'm happy with it being even. So I'm happy with these 3 numbers right here. So those are 3 favorable outcomes divided by 8. Total possible outcomes. So if I plug that into my calculator and do 3 divided by 8, I get 0.375. So this is 0.375. Our probabilities are always going to be less than 1. 1 means that it's definitely going to occur. So like if I had a probability of rolling a 1, 2, 3, 4, 5, 6, or 7, or 8, that'd be 8 out of 8, 100%. I'm going to roll one of those. Now it's possible to have events that can't occur at all. Like if I had this 8-sided die and I wanted to roll a 10, that's impossible. There are no 10s on here. It only goes up to 8. So that would be a probability of 0. So it's possible to have your probabilities go from 0 all the way up to 1. 0 means it can't occur at all. 1 means it's guaranteed to occur, 100% chance. So and events, they have to occur at the same time. Or events, you're happy with either one of them happening. All right, let's look at two-way tables now. Two-way tables is where we compare 2 different types of categories of data. Let's say that we were doing a study to find out who was going to go on vacation this summer and who was going to stay home. And we had male and female people that were taking the survey, and we're asking those males and females, are you going to go on vacation or are you going to stay home this summer? So let's say that I've got this box here, says I've got 15 males that said they're going to go on vacation. Over here I've got 10 males who said now they're going to stay home. So that means I have a total of 25 males. Okay, I've got 9 females that said they're going to go on vacation. And I've got 6 females who said they are not going to go on vacation. They're going to stay home. So I had a total of 15 females respond to the survey. And if you look at it, that's a total of 40 people. 25 males, 15 females. Now if I'm looking at vacations, I've got 15 males that said they're going on vacation, and I've got 9 females who said they're going to go on vacation. That's a total of 24 people said that they're going to go on vacation. Over here, I've got 10 people, males, that have said they're going to stay home. I've got 6 females who said they're going to stay home. That's a total of 16 people who said they're going to stay home. And it's still adding up to our grand total because 24 plus 16 equals 40. All right, so now let's look at some probabilities. If I was looking at this thing and I said, what's the probability that I was looking at males, or that I picked a random person in this survey and said that they're male? Well, males, there was a total of 25 of them. Now, what is the total possible outcomes for respondents? Well, there were 40 total possible people in the survey. So the probability that I just randomly pick a male would be 25 out of 40. So I'd do 25 divided by 40. And I can see here that 5 goes into both of these numbers, so that's 5 out of 8. And if I plug 5 out of 8 into my calculator, 5 divided by 8, I get 0.625. This is 0.625. So that's the probability that I'm going to find a male, which is better than 50% because there were more males in this one. Okay, what's the probability that I randomly picked somebody from the survey and they said they wanted to stay home? Well, a total number of people who said home was 16, and there were 40 people in the survey. So this would be 16 divided by 40. Our favorable outcome is people that said that it's home. There were 16 of those people. And then it's out of 40. So 16 out of 40, it looks like, what, 8 goes into both of those? So this would be 2 out of 5. If you plug 2 out of 5 in your calculator, that's 0.4. Okay, here's a new thing. It's got a little line here. What this means is I want the probability that I pick a female, given that, and that's what that little line means. That line means given that they're going to go on a vacation. Now what this means is I'm only looking at the people going on vacation. So how many of them were going on vacation? There were 24 females going on vacation. So that's my denominator. That's my possible outcomes. Because vacation over here, given that vacation, means that we're only looking at the females who went on vacation out of all the people that went on vacation. So we're only looking for females of those that went on vacation. So 24 went on vacation, and how many of those people that went on vacation were female? There were 9 of them. So I'm going to say 9 out of 24. It looks like, what, 3 goes into both of those? So that reduces to 3 out of 8. If I take 3 divided by 8 on my calculator, I get 0.375. 0.375, running out of room. All right, fit it. Nice. Next one, what's the probability of vacation given that they're female? Okay, so this one's a little bit different. This time, I'm only looking at the females. So there were 15 females. And this is saying, of those 15 females, how many of them went on vacation? So it's the vacation given that we're only looking at females. So that means my denominator now is the total females, 15. Of those 15 females, how many went on vacation? 9 of them did. So I'm going to say 9 out of 15. And that reduces to 3 out of 5, which is 0.6. So these are 2 separate probabilities. This one is saying females given that we're only looking at people on vacation. This one's saying looking at people going on vacation given that we're only looking at females. So the given that changes the denominator. Okay, let's look at the probability of females. Probability of females would be 15 out of total of 40. So favorable result is I found some females, and out of a total of 40 people in that. And this one reduces to, let's see, 5 goes into both of this. This is 3 out of 8, which is 0.375. All right, so that's a two-way table. Last thing that you're going to have in this set of homework is your test for independence. All right, so independence means the probability of one event does not affect the probability of the second event. And you can test if something is independent using this test. If the probability of A given that B is the same thing as the probability of A, then the events are independent. Let's go back up here and see if we can find any of these situations. So probability of A given that B equals the probability of A. So I actually do have that situation on these 2. Okay, so I'm going to call A females. And B, I'm going to call vacation. So here I've got probability of A given that B, because females given that it's vacation. And then over here I've got the probability of A, females. So we want to see if the probability of females, given that we're only looking at people on vacation, is the same as the probability of finding a female. And we see that they both gave us 0.375. What does that mean? It means that yes, we have an independent event. If we have probability of A given that B equals the probability of A, and here we do see that A given that B equals A, because they're both 0.375, that means this is an independent event. If they don't equal each other, it's called a dependent event instead. So if it's not equal, it's dependent instead. All right, that's all you got for this lesson. Enjoy.